Welcome everyone to our final virtual session of 2021. I'm Michaela Parker, Executive Director for the Academic Data Science Alliance. And today we're going to be hearing about creating interinstitutional data science pathways, streamlining access to data science education in California. But before we get started, in case you are not aware of who we are, ADSA, Academic Data Science Alliance, is a community of data science researchers and educators who take responsibility for a just, equitable future where data science approaches are thoughtfully applied in all domains for the benefit of all. On this slide is a little QR code. It'll appear in the next slides as well. You can use your mobile phone to snap that. It'll take you to our website where you can learn more about our activities, events, mission, vision, values, and how to become a member. So with that, I'll thank you for joining us, and I will now turn it over to Eric Van Dusen, who is the chair of this session. He is the Outreach and Tech Lead for the Data Science Education Program at the University of California, Berkeley. So over to you, Eric.
Thanks, Michaela. And welcome, everyone. We have a panel today with a few different speakers. I'm going to give a few slides of overview of a project that we've been working on over the past couple of years, bringing together educators across California that are sort of trying to figure out what data science education is and what is going to be and what do we have so far and what are we building. And what are the benefits from being a network while we explore this. So I'm going to have 3 points that I'll start off with and bring us back to. One is coordination. So, getting to know what the different kind of programs are. There's a lot of people coming into this space with different types of backgrounds and different types of visions of what data science is going to be. Second is on process. So we're doing a lot about the logistics of getting this to work for students to move across community college, Cal State, and University of California's. And then finally with support. So supporting with infrastructure, with curriculum, with training, and sharing materials across institutions. Really quickly, if folks are not from California, there is the California Master Plan from Education from, I think, 1970 with Governor Brown. But today this means there are 3 huge networks of public universities. At the UC level, there's 220,000 students with about 30% of those students being transferred. CSU level, around 500,000 students with up to 70% of those being transfers. And at the community college level, 1.8 million students, of which 20% go on to transfer somewhere else. At the community college level, things are really diverse. There are mostly 2-year programs. There are some 4-year programs. There's many certificates. There's many people coming in with really varied backgrounds. But some of what we're seeing, what's motivating in this is students could come in at a 2-year associate's degree, get the credits they need to transfer, and finish at a 4-year degree at a CSU, and maybe onto a UC for master's. So how do we make this fit together in a way that's pro-student in this new area of study? So we have a smaller subset of teachers and researchers who we have had a board meeting over the past year to sort of talk through some of these problems on a quarterly basis. With members from UC, CSUs, and some from community colleges and some from private as well. And we've been meeting to talk about articulation, about what key classes are, what math requirements are, and sort of mapping what's happening at the different levels. And so the 3 panelists that will come after me will talk about mapping or giving examples of what's going on at these different tiers. Last February, we had a big meeting where we tried to bring in people from all sorts of institutions. We had 149 attendees from 65 different institutions, of which 25% had a data science major at their institute. We had 26 had a minor and 18 had a certificate program. So people are building out into the space, and we'll do this again February, and this percentage will be going up. Programs are going online constantly right now. There's some links here for the conference website and we'll be having another conference in February again of this year if you're interested to join. So what are some of the things we've been working on? So we have been doing sort of a survey and a mapping of what programs are out there at the UC, CSU, and community college level. And in no way are we comprehensive, but we're trying to keep up with what's out there. We've been trying to reach out to the chancellor's office and sort of keep them aware at CSU chancellor's office and the community college chancellor's office as well. And these has also provide linkages for some NSF proposals that I'll talk about in a sec. One of the big things we've been trying to take on is transfer and articulation. So we had, facilitated conversations across community colleges, what's been accepted, what was in your proposal. We have a few pilot institutions that have gotten articulated classes early on, and that's helpful for others following on to know what class can get articulated. And a lot of that is based around a fundamentals of data science class that is basically a common, set of things in the introductory class between UC San Diego, UC Berkeley, and UC Santa Barbara. That means that an additional community college instructor could get their class articulated at these 3 places because they're following a common template. We've also been talking about what's the math background, how much do people at community college have the background for this class, or what other sort of mathematics classes would it be linked to? And finally, we've had a useful conversation with UC Office of the President, who does not actually facilitate articulation, but can be sort of a place for communication and sort of be a place to convene what the articulation officers are who mediate this in the one-to-one that articulation consists of. Finally, we've been doing a lot of support around infrastructure and curriculum, creating resources, training up teachers, bringing people in for boot camps, and we have been piloting a partnership with a nonprofit and an NSF-funded cloud project that I'll talk about a little bit. First of all, there have been 3 of these HDR data science core grants that have been to members of the California Alliance, one in the Central Coast, Cal Poly and UCSB started that. Then their newer ones from this year are for the Inland Empire, UC Riverside leading that, and Orange County with UC Irvine leading that. These are all really diverse, they're really different, but what we see here is like NSF is interested in these kind of proposals that link UC, CSU, and community college. And we need to have partnerships and friendships and know what people are doing at these different levels. And so, these relationships are growing not just at this statewide California Alliance level, but within these subregions as well. So all these efforts have happened as sort of outside of California Alliance, but they're also places where we're creating networks and bringing people in and learning from what their collaborations have meant as well. And what UC Berkeley, for me speaking from UC Berkeley, a little example of how we've leaned into this California Alliance is a lot of it came out of people that have met at a national workshop that we carry out every June, and our interest is like creating a cohort of younger teachers who are interested in this area and sort of like sharing the open source curricular materials that a lot of the new data science teaching materials are made in this open source way. We also want to support transferred students. So UC Berkeley has a transfer seminar for people who transfer in. We also have a transfer mentors program for people that have transferred into our major to mentor additional people coming into the major. And then the big collaborations that I had talked about for the community colleges are from NSF Cloud Bank, who's providing free cloud credits, and engineer side, like to set up Jupyter Hubs, and then 2I2C, who's actually deploying the Jupyter Hubs and supporting that as an administrative linkage. And we can touch on those numbers when we get to Solomon's presentation on community colleges. But right now, I'd like to bring in Aaron Frankel to give the overview of the UC.
Thanks, Eric. So I'm Aaron Frankel. I'm an assistant teaching professor at University of California, San Diego. In the last 2 years, I chaired the undergraduate program in data science at the university. So data science is found across all of the UCs, actually. But the UC system is large and it's varied. And so the way that data science has appeared at various campuses ranges, it runs the gamut. It ranges from full-on academic divisions to individual courses in data science to organic student-led groups. One commonality across all of these instances really is that data science you tend to see it be practice or application based because it's not really a well-defined academic field yet. That's sort of the main differentiator you see from current and well-established academic programs like stats and CS, where you might find data science most often. So I'm going to kind of go through and give an overview of, or not so much an overview, but an example or two of campuses that fall into each of these categories, to see what's happening and see what's happening and sort of the initiatives and the challenges that each campus is facing. So next slide. Thanks. Okay, so one category that you see, which is publicly, very publicly visible, is new data science majors and minors that are their own standalone programs. So you see this with UC San Diego, you see this at UC Berkeley. I'm going to focus on UCSD because that's where I'm from. But generally, data science programs involve departments across not only different departments, but different schools like engineering, sciences, social sciences. And so one approach that, for example, Berkeley and San Diego have taken is to actually establish, have data science established in their own academic division or unit. And so at UCSD, for example, we have the Data Science Institute, which is about 4 years old now. We have our own faculty, about 15 or so full-time faculty, our own courses, and about a major of about 800 students and a minor of close to 200 at this point. The challenges of creating your own program, right, your own academic unit, is it's very resource intensive. You need your own faculty, your own course development, your own infrastructure. And you have to sort of decide, for example, what articulation might look like, for your own data science branded courses and what your time to degree looks like. However, what you get is you get to sort of lay out what you feel like the future of data science should look like in an academic institution. So to the right, what you see is our lower division sequence at UCSD can core sequence, aside from the math calculus sequence and linear algebra, every data science student actually takes 6 data science courses that are very specific to the data science department. They don't really exist elsewhere, to sort of put together our special major. This, of course, lets us create a bespoke, handcrafted major that is sometimes feels like a double major squashed to one. And so, there's the advantage, but the disadvantage, of course, is, what exactly are these classes and just will they exist at other universities? Okay, next slide. The other model that you see data science majors coming out of is where you have 1 or 2 departments, existing departments, collaborate or sponsor, they're a data science major, within their area. And so, the oldest example of this in the UC system is at Irvine, as a collaboration between statistics and computer science, founded in 2015. And the program structure looks like stats plus computing plus practice, complete with capstone. It's a pretty popular major. But even here, what you see when you have two departments sponsoring it is that the major still needs a primary home. And in this case, it's actually housed neither in statistics or computer science, but in the school, the I School, in the School of Information. And it where that home is really influences the flavor of the major. What you also see is single majors sponsoring or creating data science programs through concentrations in the existing majors. You see this all over. It's not mutually exclusive, for example, to these standalone programs. For example, UCSD has data science or machine learning concentrations in cognitive science, in the electrical engineering department, in the computer science department. And so this is, these programs are also pervasive across the campus, all the campuses. Okay. And then lastly, and this is really where I want to focus and home in, is just data science courses, right? Popping up in departments across campuses across UC. And you see these courses occur in sort of two flavors. One, you have data science courses, and then you have courses that use data science, right? They can be attached to a data science program, but they can also be, just coming from a faculty who's inspired to create their own data science course. And so UC Berkeley really, among the UCs has really paved the way for success here with, Data 8 as sort of an intro, a massively popular introduction to data science. But you also see other initiatives at Berkeley, which sort of, for example, connectors and modules, which are sort of baby introductions to data science within a specific context. For example, these modules, as faculty teaching whatever course they might be teaching, modules sort of make it easy to insert a few lessons that highlight how data science can be used within a subject. And within an existing course to introduce students, how data science is used in practice. At UCSD, I just want to highlight actually, so cognitive science has a massively popular, about 1,000 students a year, intro to data science course that's been taught, was developed by Brad Wojtek, and has been taught since 2014. And this course actually is largely what sort of, I wouldn't say not necessarily created, but inspired, right, plans for a major in data science at UCSD in the first place. Having courses sort of scattered through, a university, courses on data science scattered across the university, really highlights actually how many pathways there are into data science. And it helps sort of broaden those pathways, right? And funnel people not only into a major, but just using data science and exposure to data science within their work and within their lives. And this is one of the one of the places in which data science can really shine in how many areas it comes up to create a diverse community and within data science from across the university that is honestly is very unique across, a unique opportunity in a STEM field. Next slide. So what are some of the challenges in bringing data science to a campus? And many of these I've already mentioned. Of course, staffing these courses, these practice-based courses can be very difficult. Interdisciplinary courses are hard to find instruction for. And then of course, when you're combining two STEM fields and then adding in practice, time to graduation can be very difficult with a data science major. You have very large prerequisite chains when you're combining math and CS in this way. Specialized courses, of course, as Eric had mentioned, it makes articulation quite difficult. And one of the things that we're trying to do is coordinate among each other so that we have at least have similar themes among our courses so that we understand how these courses should transfer. And then of course, being sort of, coming out of two different STEM fields, combining two different STEM fields, we at UCSD have seen, some of the same challenges that other STEM fields, for example, computer science, have seen in achievement gaps, particularly, which is particularly acute for URM students, as well as women in data science. And this is something that we really want to approach and work on early from the beginning because of what I mentioned on the last slide with sort of the, all of the different pathways available to get into data science, right? We should really embrace that and sort of, and try to let that aspect shine.
Awesome. Thank you, Aaron. Now we're over to Judith Canner.
All right. Hello, my name is Judith Canner, and I am a professor of statistics at Cal State Monterey Bay. So the CSU system is the nation's largest four-year public university system. We have 23 campuses, 21 of which are classified as Hispanic serving institutions, which means more than a third of our students have checked that box. And 14 campuses that also qualify as Asian Pacific Islander and Native American serving institutions. And so this is really a very diverse system. We also have really high levels of enrollment across systems of first generation, students that are first generation, so the first in their families to go to college and graduate. And it's a system that has been growing. We have about 500,000 students enrolled annually, 4 million alumni, and campuses range all over in size. So for instance, my campus is a little over 7,000, and then we have places like Northridge and that's more, and Fullerton, which are more like 45,000. So it's really quite a diverse set of campuses. And we are here to serve the community. So unlike the UCs, we do not have PhD programs unless they are in partnerships with UCs or our professional type programs like EDs. But we do have master's programs, and we are here mostly as teaching universities, although we also do a fair amount of research as well. So how data science has sort of sprung up here in the CSU system is in a bunch of different ways. So my own institution, which I'll talk more about, started with a concentration within computer science, and now we've moved on to a minor plus some other interdisciplinary programs. Cal State East Bay, which has great undergrad and grad statistics programs. It's really linked within the stats program. We have some other pieces springing up differently within psychology at SFSU. Cal Poly, San Luis Obispo has a minor that is very, very, very large, but is really shared between CS and stat students. And so once they share it, it sort of shrinks down to be a true minor. And then Chico also has a data science initiative. And so you can see a little more detail on the next slide, where we have a bunch of different things that have been starting over the last few years. It looks different at each institution. So I'm going to share a little bit more about my institution and how we've started our own data science initiatives here, and also sort of relate that to some of the bigger things that are happening within the CSU system. So for instance, as I mentioned, we started with a concentration in data science within our computer science major. And so because of that, it was very computer science focused. And the reality was they were learning a lot about the programming side, and they were getting into neural nets and advanced machine learning. But the students were much more focused on the programming aspect, computational aspect, than maybe more of the background and theory and the statistics and statistical learning aspects. And so we started our statistics major, started as a concentration around the same time as the data science concentration. And we elevated that to a full major and have been building out courses that will really introduce students to data science ideas throughout the curriculum. And then we had these two minors, a computer science minor and a statistics minor. So this was sort of where you saw it programmatically appearing in various ways. But especially in the computer science minor and statistics minor, the courses that they took did not necessarily have to be the data science centric courses. I've listed the data science centric courses they could have taken for each minor, but they could have also taken a variety of other statistics courses or computer science courses that really are not what we might define as data science. So as we also had in other programs, in the next slide I'll show you, we had some things like in our biology program, they had started developing a practical computing course, which introduced students to Unix and Python, and even some SQL programming to help them deal really with bioinformatics. And then just a few years ago, our environmental science program started a data analysis concentration, really focusing a little more on GIS and spatial analysis, that area, but they did start to incorporate some of our statistics classes into that concentration as well. So we see some sort of interdisciplinary growth and sharing. And all of these programs, by the way, are contained within a single college, the College of Science. And we have business, which has sort of been doing their own thing as well, more on the business analytics side of data science. So when we started thinking about, okay, how do we really formalize data science across all of these programs and curriculum, what we'll see on the next slide is that we really started with sort of these disjointed pathways and things. We had some statistics stuff happening in one area. We had this computer science track, which is kind of disconnected from everything else and required a lot of programming. We had this sort of bio sort of part of the program. And so we wanted to see if we could try to connect those to create a really cohesive data science minor that all students could access. But we stumbled basically into some negotiations that needed to happen about how data science was taught, who owns it, where does it go? And so what ended up happening is, as you'll see on the next slide, we, in a lot of discussions with computer science, because we don't have the capacity or the background necessarily in the statistics department to really get into things like neural nets and the more advanced machine learning type of things. We didn't want to build an analogous course in statistics, right? So we wanted to build on that course. But because that course is in computer science, they required a certain amount of programming that was required for them to be able to take those courses. And then, so we started basically a negotiation process. How do we get our students who maybe have had some intro stat, which is our general education course, into some other courses that would basically get them into machine learning? And this led to the development of some bridge courses, one focused on Python programming, which we also were able to get certified as we have upper division general education. And then we created a new data science course, which has this sort of prereq of intro stat and programming before we go into it to help students move into that machine learning pathway. But it's not quite connected because computer science is still not convinced that that will be enough to get students prepared for machine learning. So where we ended up with is a minor. In the next slide, you'll see sort of the outline with sort of two pathways, a machine learning pathway, sort of a general pathway. So that way, the students who are more within the College of Science have taken calculus, have taken more programming, can more easily go into the machine learning. But the students who are starting in maybe the intro stat, the non-science, College of Science majors, have sort of another pathway, but at least they can get to some levels of data science in those pathways. So that took about 2 years of negotiation, including during the pandemic, to get to. So where are we going with all of this? So if you go to the next slide, we also are trying to figure out how to get that data science our students from data science, sort of move them on to another, to the next level. If they need to go to a master's, need to go to PhD, or get them into industry. So in 2015, we were actually awarded an NIH grant to support a summer research program in collaboration with the UC Santa Cruz Genomics Institution, which included both data science, bioinformatics, and a bunch of other stuff too. It's sort of this big amalgam of lots and lots of different programs. And so this was we did an 8-week summer research program where they were able to continue their research into semesters, building on the fact that both Monterey and Santa Cruz were just about 45 minutes away from each other. So with both Zoom, but also the ability to easily drive up to Santa Cruz during the semester if they needed to meet with their advisors or collaborators, they could. Really created this nice connection point for our students to continue to do research at UC Santa Cruz, or for those faculty who are overseeing the research at UC Santa Cruz to then collaborate with researchers down at CSUMB. And so students did a whole slew of professional development to help them prepare for grad school and to apply for grad school. And we also sent them to several conferences, SACNAS, Aberkims, and then we also have a special conference in the CSU called CSUPerb, which is for programs related and education related to biotechnology. And that program has also been really trying to think about how to push, even though it's biotechnology, how do we get data science really growing within the CSU? And thinking more about this community college to CSU to UC pipeline within this program, something that was unique about it is we were selecting CSUMB students only for the program. So they only had to compete among themselves, not with other students. And it really allowed us to find students who had transferred in, who often are coming in not knowing how to get to grad school yet because they just haven't learned that hidden curriculum, if you will. And we were able to find them and encourage them to apply and really help them in the process with mentors to help them prepare for the summer to do these summer research programs, which is a lot of students, they realize they want to go to grad school early, they can do more than one summer research program and get this professional development that goes along with it. But for students who transfer in, that's a much more challenging task because they only really have one summer once they get to their 4-year institution to figure things out. And so we have to think about that pipeline process to really help them to get what they need to be competitive for grad school applications. So these summer research programs are great because they sort of showcase the student to UC Santa Cruz researchers who then will recruit them into their labs. And we've had multiple students where that has been the case, where they were then recruited into labs at UC Santa Cruz for their master's or PhD programs. Additional connections in that CSU UC pipeline is we have a postdoc training program where postdocs from UC Santa Cruz are learning how to teach at CSUMB and also do mentoring through various collaborations for students who are in difficult courses. I mentioned already, research collaborations have begun between the two institutions as well. And then when we do professional development, we sort of share that between institutions. So students can now, especially nowadays, can more easily Zoom into seminars or and vice versa. So that's just one example of sort of a pipeline, but we really do need to bring in the community colleges more into our pipeline. And Hartnell and Monterey Peninsula College, which are near, and Cabrillo, which are all nearby us. We've been working with them to build what are called 2+2 agreements because we have these transfer agreements for if they have an associate's, but they don't, we want to give them sort of this guaranteed pathway of being able to finish in 4 years if they complete a certain set of courses without having to go through the associate's process. Because that's not always needed. And sometimes for these new programs like statistics, there's not even an associates for transfer agreement in existence. So these 2+2 agreements for these data science programs are really helpful locally to build out that transfer, that connection, that pathway between community colleges and the CSUs. The other thing you'll notice that we're kind of missing is a really truly introductory data science course. Right now, all of our courses that have the name data science in them require at least a semester of programming. And we do think that that's still too high, but it was basically what we negotiated around based on sort of restrictions from administration and departments. And so figuring out how to create that true introductory data science course, similar to the Data 8 course Aaron mentioned, but also something that's going to be able to be articulated to, that the community colleges around us could teach and know that it will articulate to our campus as well. We're also looking at new programs, such as a data science concentration in statistics and a bioinformatics concentration in biology. We're trying to find more ways to do interdisciplinary collaborations for teaching and research across departments. And we actually just submitted a grant as a joint between statistics, computer science, and biology again, to look into that. And then one of the things we're really struggling with on our campus, because we are a smaller campus, is computational support. Right now, our IT doesn't really support things like Linux, or even the server we use for our studio. We have to support a lot of that internally within our departments, which puts a burden on the departments to provide IT support. So I have to contact a coworker anytime I have an issue with our server, which isn't really efficient, if we say. And this issue of computational support isn't unique to my campus, and neither are some of these other restrictions or issues that I've mentioned, such as articulation. It's a constant sort of communication, collaboration. And if you'll see on the next slide, I mentioned the CSUPerb group. They actually did a report based on a survey on the computational needs of the CSU system. And we've been trying to think about ways to, among our 23 campuses, which are also resourced differently. San Diego State, for instance, I think utilizes UC San Diego supercomputer, and they get access to that, but we don't have access to that. And so how do we really share resources and create resources at sort of the higher level, as well as providing, we have some programs now that are providing things like iPads to students, but iPads are not actually that conducive for a lot of data science because they don't work as a desktop, and they don't really run as Linux. And so web-based support is really needed for those sorts of computational needs, like some of the things Eric will be talking about in the community colleges. And then training as well, right? I don't know about you all, but finding and then hiring data scientists who want to teach, we're in competition with a lot of people for the kind of thing, for that process. And so it works better to train the faculty that are already here to be able to use and access computational resources. But of course, that takes time and energy, and for both the faculty member and also for those organizing the trainings. So as we're moving forward, again, this is not just a CSUMB problem, it's a CSU problem, and I think also a community college problem, if I can be bold enough to say, that we really do have to think about how we are resourcing the computational needs of campuses in order to keep building data science programming, both on the faculty training, student access, and just availability side of things. So with that, I will turn it over to our community colleges.
My name is Solomon Russell. I'm a computer science professor at El Camino College. El Camino College is located in Los Angeles County, about 10 minutes south of LAX. So right here on this slide is just a few of the many community colleges across California. There are 116 community colleges in California, serving about 1.8 million students. The amount of students that we get are very various. They have a lot of different backgrounds. There are students that are returning to school. There are students that are coming straight from high school. So we deal with a wide range of the community. So for some of the schools up here, we all have somewhat different demographics, but we have common goals of wanting to present data science and give our students opportunities. So San Jose Community College was one of the first community colleges to actually teach the data science class, Data 8-like class from Berkeley. Schools like Santa Barbara City College, they're part of the Central Coast Data Science Partnership with Cal State San Bernardino, also with UC Santa Barbara, and then also Cal Poly SLO. City College of San Francisco, they are teaching Data 8 this semester. They've done a lot of work around teacher education, of really building that amount of expertise that's needed in order to teach this class. Palomar College, a college that I just talked to a few months ago in one of the meetings that was kind of like created by the California Alliance. They actually have their own data analytics program, and they've had that for a number of years. Skyline College did an amazing job by actually getting a certain general education requirement through with their course. El Camino College, of which I'm a professor, we're working on the next data science course after CS8, and Antelope Valley College is a college in a rural area of California, which they've already done some innovative things around statistics. Great, next, thank you. So one thing that Judith talked about was the computational support. And at the community college level, we would not be able to offer the amount of support for our students in terms of computing costs, the expertise in order to make the technology work for students without the help of this I2C program pilot. So I'm one of 7 colleges this semester that are using 2I2C. This is the infrastructure that allows our students to be able to log in through our learning management system to go straight to their Jupyter labs, their Jupyter assignments for the class. Without this, we would not be able to teach the course. Great, next slide. Great. These are some of the other course materials that were provided to us that actually allows us to get up to speed. So we were given a Canvas page that we connected to our learning management system that allows us to go through and offer this course. And at the same time, this was very useful for professors to be able to get up to speed to actually teach this material. These materials allows us to share expertise across campuses. I've talked to other community colleges where we've gone over these types of materials, and I've actually shared some of the additions that we've made and things that we've tweaked with other schools. Great, next. Great, so collaboration. So this is a big area for community colleges and something that's really been useful to us at El Camino College. So I brought data science to El Camino, just basically from another course that we were teaching here, another Berkeley course, and that's where I heard about data science. It was me being the evangelist. It was me also being the person across campus that would write up the materials, that would do all the legwork. But ultimately, it feels a little bit like Sisyphus, just pushing a rock up a hill without support. So the collaboration that we've been able to have with other community colleges, Cal States and UCs have been so beneficial, and they've been beneficial in a number of ways. So one is the national workshop that Berkeley actually holds for us every summer. That first year, when I got really excited about it, I was able to get another professor in the mathematics division, in the mathematics department, to actually go to the conference and become excited as well. So it wasn't just me being an evangelist on campus, there was a force multiplier. And to be able to have that type of event meant so much. Based on that event, we were able to get other people excited and find that there were already efforts happening in our community around data science. There was a student who was very, very motivated, who wound up starting this first annual community college data science conference. We co-hosted it, the Associated Students Organization at El Camino co-hosted it with Berkeley, and we invited a number of community colleges actually across the nation. We had students from Maryland show up, as well as California. Right? The communities of practice that we're able to create has been also really beneficial. One nice thing is that along with the formalized meetings that we have with UCs and CSUs is that we have a lot of informal meetings. So I've been able to talk to Pasadena City College as they're starting their program in the next few semesters, and talk to them about like what are the things that are happening with me with the curriculum. They've sent students that are about to graduate that don't have the opportunity to take this course at their school to our school. So there's a lot of cross communication that's been happening. Other schools that have been interested or hear about data science, we've met with, and they've gone on to like work with Berkeley. So it's a lot of communities of practice, which have been a really big benefit, especially because data science doesn't have its own department at this school. And without this, it would just be me or just a couple other people trying to push it. We have grant proposals because of these collaborations. El Camino with also Santa Barbara City College, we unsuccessfully proposed a grant around data science. But with those conversations, we were actually able to see that we have some commonalities as well as some like differences, right? So there are certain things that we focus in on because of the areas that we have and the students that show up that are applicable to Santa Barbara City College, even though they may have different demographics. The biggest thing in terms of navigation of collaboration has been navigating articulation. So this is a huge thing that we're going to come back to in the next slide. But most of the conversations that we have in our meetings is around how do we get this class in front of students and how do we make it work for them depending on where they go in the future, right? We are developing new data science courses, and this alliance has been very useful because I have a direct line to people that are data scientists. I'm coming at data science as a learner who's trying to help other learners. So when I try to create new classes, I look at what is already existing. I look at Aaron's class at UC San Diego, his data science 80 class, to figure out what are the next things that make sense to be able to teach students as they progress along. One thing that we've also talked about a lot with articulation agreements is also the math requirements for data science. So there is a lot of things that have gone on at the community college level in terms of math in the last couple of years. And we're trying to figure out how does data science and math for data science fit into what we already offer our students. Where does linear algebra fit in? Right now, it's usually at the end of a calculus sequence. Is that necessary for data scientists? Probably not. What do we create for them that also has wide applicability? And we discuss our different pathways for creating certificates and associate's degrees. Right now, we have a student-centered funding formula at community colleges. So we are incentivized to offer certificates and also associate's degrees. How do we get those so that if a student comes out with a certificate or an associate's degree that is actually meaningful in the workplace or useful to be able to get into a four-year institution? And finally, identifying pathways. So there are these 2+2 type of partnerships where community colleges will connect with also CSUs that are in the area, and how are those partnerships working? Great. Next slide. So here's a slide just about articulation. And on the left-hand side is a picture of us at El Camino College and all the different places, some of the different places that we're trying to send our students, right? CSUs, private institutions, UCs. And when I think about this, I think of an analogy of the old switchboard operators, right? Where one person's calling and you have to figure out where you're going to place this call and do a lot of work. Now, this was ultimately automated, but this is not something that can be automated for community colleges, right? Because each student is different, each student has different needs. And how do we build data science in a way that's able to serve the most students and also serve them for their specific needs? With articulation, there are a lot of areas that we have to look at: articulating to CSUs, looking at the course identification numbering system. How do we get courses to count for other community colleges and for CSUs? And how do we get them to count for general education, quantified reasoning for CSUs and also the UC system? Great. Next slide. Great. So now at El Camino College, we in the last year have created 2 new data science courses, one based off of Berkeley's Data 8, and we call ours Foundations of Data Science. We offer it through the computer science department, but it's in connection with the mathematics division because we are part of the mathematics division, and we also have faculty that are math faculty teaching with us. We offered it for the first time in spring of 2021 with 4 sections, and we had 71 students. We actually could have added more sections, but we didn't have the teaching capacity to do that. And we were able to get articulation with UC Berkeley and also UC San Diego. We also have another course that was taught for the first time in spring 2021. That was a data-driven persuasion course, which is very similar to a statistics course, but with a little bit more emphasis on story, narratives, and being able to use persuasive language in order to make points. And that has been approved for UC, CSUs, and has the quantitative reasoning and mathematical concepts certifications. Great, next slide. So this is, I think, really important, especially at the community college level and really across all our institutions, is looking at the equity gaps that exist and what can data science do to change those things. So if you look at the top left kind of arrow, you'll see that the different ethnicities that we have. One that really stood out to me is our African-American students. Traditionally, we have about 5%, 4 or 5% in our computer science classes. For the first semester that we ran this course, we actually had 12, almost 13%, which is how African-Americans are represented at the school overall. But as we look to the bottom right, we see that the course completion rates for those with prior CS experience and also Black and Hispanic students were much lower than completion rates of Asian and also white students. So as we continue to teach this, we think about how can we tweak what's already there in order to make it work for all of our students. Great, next slide. Great. So these are some of the courses that we already offer. Statistics, we offer a Python course, this Foundations of Data Science course, and then also the Principles course. We are proposing that. We're in the process. That's going to be probably closely tied to Berkeley's Data 100 and also UC San Diego's Data Computer Science or a Data Science 80 course. But then we're thinking about additional courses that we can add to that in order to get to that certificate or an associate's degree, a data structures course, possibly that data-driven persuasion course. What type of math course do we need? So with the math faculty, we're starting to have these conversations of the equity issue that they have there, that if we have a linear algebra course, how can we make that accessible to students without having to go through the computer science sequence? And then we also would like to add databases and then also maybe even a course connecting it with AWS. Next slide. So the phases that we ultimately we're actually challenged with are how do we find faculty to teach new data science courses? So we are relying pretty much on the model that we're going to have to grow our expertise from within, and that has been benefited by our connections with Berkeley, being able to have their resources as we use them to teach ourselves. How do we continue to articulate our courses and then also to get them to count for certain areas in terms of breadth requirements at the UC and the CSU systems? And long-term, we think about an associate's degree, a certificate, establishing the needs that industry have for us and for our students, and ultimately maybe even creating a data science department in the next few years. Great, Next slide. And this is an overview of just some of the community colleges that are now teaching and the different stages that they're in and requirements that they have on some of their courses. Okay, thank you.
Thanks, Solomon. This has been really great. There was a question from Nick Horton about whether we will definitely post the slides later because there's a lot to take in and there's links to different stuff. Right at the end here, I'd like to bring in a student that we work with who's been fundamental in coordinating the California Alliance, but has her own pathway where she, came from community college into study data science at the master's level currently right now. Kseniya, do you want to give a few words?
My name is Xenia. I am a graduate student at UC Berkeley. I initially transferred from Berkeley City College and I majored in cognitive science, which is not a data science major, as you can tell, but considering the fact that I enrolled with linguistics and completely changed my major to something more computational after taking data 8, kind of tells you a lot about how exciting the data science major or the data science program was for me initially, and the data science classes are for me. I'm currently leading the external adoption team at UC Berkeley, and I have joined the Division of Data Sciences and have been on a lot of projects throughout the years. I joined right after taking data 8. So I'm excited to be here today with you, and I'll be able to answer some of your questions.
Great. I wanted to turn to a couple of the questions in the chat. The first was from Nick Horton. Are there learning outcomes for the Intro to Data Science class? Yeah, I will say there are, and there's a common set of things that happen. One thing I will flag is that UC Berkeley's on semesters and San Diego and Santa Barbara are on quarters. So that's a perennial topic of how do you fit something in 15 weeks versus 10 weeks. The other thing that I will flag is UCSD did a great set of these little write-ups of what does your data science student know at different parts of their learning pathway. Thanks for adjusting it to panel view. This is great. The second question is, how do pathways work for students? How does Intro to Data Science class relate to Intro to CS or Intro to Stats? Are there constraints on what comes first? I think Judith touched on this in her talk. So I think we heard that was definitely an issue that affected the program design. This could be different each place. I don't know if Aaron and Solomon, you want to jump on with your perspectives on this one.
Sure. Or on either of those questions? Yes. I would just mention, I suppose, that for what the learning outcomes are in teaching data 8. So I've I taught on the quarter system, and it's actually the the first required course for our major, and it is required before actually moving on to any of our courses. So students have to take it first. I would say that personally, when I teach it, the learning outcomes are really to not only get, a lot of intro to data science classes, maybe to actually to give a student an understanding of what data science is. But the cool thing about data 8, or our DSC 10 is it's to give a student an actual tangible feel of what it's like to do data science. And so in enabling that, the key components really are, on one side, a basic understanding of tabular manipulation and computation to be able to extract attributes and observations from tables, to understand what data is. And then on the other side is get a feel for inference through variation, especially using simulation. And so those are really what we want our students to take away from the course in our 10-week offering. I'll let Solomon, you have any What's your experience teaching it?
Sure. So I'll talk about the second question that was put up, and what constraints are on the course. So one of the great things about Data 8 is that there are no constraints, right? So there aren't a lot of barriers for students to be able to figure out what is data science. So they don't have to necessarily take a computer science course or a statistics course. Now that may be advantageous, which is some of the data that we're seeing possibly might be the cause of some of the success rates or completion rates. But it's important to note that one of the great things about this class is that you can come in with just some algebra background and take the course and be successful. Now, how is it different from our computer science courses? At a community college, we really have to streamline. We don't have the capacity to have a lot of different tracks, right? So we are looking at, our computer science intro courses, especially the ones in Python, being taught in some way in a sequence with data science so that students are coming out with the expertise that they need. But this is definitely not a replacement for that course, or nor is it a replacement for like a statistics course. It's a little bit of those things just to give you kind of like a feel for the discipline.
Nice. Judith, do you want to jump in and talk about the pathways question?
Sure. So the path, this is something I think that's come up a lot because of where data science has popped up in at the different CSUs, and sort of, I hate to use this term, but who owns it. And we have flexibility in general education. You know, we could create an intro data science course as a general education course, but we do have to be. There's a lot of there's not a lot of support for creating courses that don't map somewhere or aren't required somewhere. So we were really surprised, actually. They kind of let us get away with a data science course that's only truly required for the minor, but anybody could take when we're trying to get it basically required or offered as an elective option in other majors so that it doesn't hang out uncompleted. And that's a resource issue, right? If courses aren't enrolled and they aren't required by a major, it's not going to get offered. So that's something, no matter how cool the elective is. So that's something we always have to be thinking about, is not just the pathway, but also the the requirement for it, getting students into the course. And then with transfer, the other thing we have to think about is with transfer students, we have certain obligations to them based on how they transfer into the CSU. And so we don't want to do anything in any of our programs that creates basically would make them have to take more than 60 units in 2 years to finish their degree program, depending on how they transfer in. And that can be really restrictive. Students can opt out of that guarantee, but that's something that's always in our mind as well. So for our transfer students, is thinking about that pathway. And that's why it's so important to think about what they can do at the community college before they come to here. And I'll say the associates for transfer that we have for mathematics is pretty restrictive. And it's outdated in my mind as far as what is allowed or what students take for their math associate's degree and then transfer in, and it's not very conducive. And computer science, I don't think, is much better, honestly. It's not really conducive to getting them into data science or statistics quickly. So it actually delays them a lot more in some ways. So they don't even get to experience it as potentially in their first 2 years. They wouldn't get to take statistics or data science. So again, going back to what Solomon was saying, is it's so important to think about how we can build on existing classes and classes that will transfer, because we have these CID numbers, and if it qualifies as this, it transfers as this, and there's these big pages full of agreements that are super complicated, and we pay people money to help interpret to our students. And so it is challenging to work within the current system. And we have to constantly be thinking about what is going to serve the most students, and because we don't have a lot of leeway for thinking about individuals.
Great, thank you. Go, Aaron.
Yeah, I just wanted to mention for pathways at UCSD and just what the major, what our data science courses, sort of how they relate to, for example, like intro stats or the math courses students might have to take, like linear algebra. Typically, we have 3 tracks that are 3, I would say, parallel threads running through our major that every student has to engage with. One is sort of the stats modeling side, one is computation and coding, and then the third is sort of domain application. And students are taking, we have a fairly rigid and chock full of units major, but students are taking modeling and stats and coding at the same time, basically through the entirety of their of college. And then with domain application, there's a lot of flexibility and creativity to learn about places where data science are used at the same time. And one thing that I'd highlight about our program is that we have, I'd call them like, touch points where we teach courses on sort of the art of data science, which really don't fit within any other department in the university. And so the freshmen start with our version of Data 8 as an introduction, and then they start taking coding and stats. And then we make them come back their sophomore year and take intro sort of data science in practice, DSC 80, so that they have to apply what they learned on those 2 parallel threads. And then at the end, we have a capstone that all majors take their final year, where they kind of come back together and apply sort of the 2 threads into one practical project. And so this is the best way that we can to kind of stay flexible, but really still have students feel like they're not just double majoring, right?
Thank you. I don't know. Sorry. The questions in the chat. There was this one on federal role, and this is, I do not know about this, but federal role of facilitating the role of 2-year colleges in building and broadening the data science pipeline and workforce. And Aaron mentioned the HDR grants, which are sort of in this space of like linking 4-year colleges at UC and CSU with community colleges. I don't know, Solomon, if you.
In terms of in terms of data science, I'm not too up on what initiatives there are for data science. I know that, at the national level, in terms of computer science, that there is a big push around like computer science principles courses, of which some of those courses actually do involve data science. But in terms of specifically data science, I'm not quite sure what the big push is at the national level.
Okay.
As my experience with, I applied for one of these, NSF HDR grants and didn't get it. But one thing that I learned, and kind of to echo Solomon, it was wonderful, regardless, as a way of coordinating with San Diego State, as well as some of our local community colleges. But one of the core components in that call was, for training a future data science workforce. There was an expectation of, maybe not regional, but at least thematic collaboration, across different types of institutions. But beyond that, I'm not aware.
We have a new question that I'm going to throw Judith's way that mentions the Park City report. specifying, which I think is AMSTAT, if I'm correct. And that's not
It's
just.
It's like I mean, AMSTAT was involved, but
Okay.
I also know that they had, I mean, Nick Horton somewhere here, I believe he might have been involved too. So Park City is actually what we built I use the outcomes to build our data science minor around. So yeah, this is a great question. Math for data science, 1 and 2. Yes. So here's some things that have been happening across the board. So this has been a discussion. I'm like, personally, I'm getting ready to just throw out the entirety of lower division math sequence. Like, why do we start in calculus? Calculus, yes, is important, but like, why? Like, why do we not start with application? Why do we not start with statistics? Why do we not start with, like, we create this big long sequence before students actually get into actual like applications. And so, yeah, the question is the Park City report specifies math for data science 1 and 2. So here's some things that are happening, both on the national and locally. So I know groups like, so a great state institution in Minnesota, Winona State, who's been kind of at the front end of getting data science programs and majors and things going. They've been exploring these math for data science courses. I know folks at, I believe, Davidson, Tim Chartier, who's doing work on linear algebra. And I'm actually a part of a group with the Mathematical Association of America. We have a curriculum, basically undergraduate program guidelines for mathematics majors. And I'm a part of a subgroup called Curriculum Renewal across the first 2 years, or CRAFTY. And we are meeting in January to talk about what does math for, like, what is the future of our math major and of this specifically the first 2 years of mathematics. Because I think we really do have to rethink what this looks like, not just because of data science, but in general, right? We want to think about, data science, statistics, but also applied mathematics. It really, there are ways, and people still think linear algebra for elementary linear algebra somehow requires calculus. And I'm like, no, you could teach that without calculus if you focus on the right topics. So it really, I think, is going to take some creativity, but again, that system is a challenge. So why don't we just teach math for data science courses? Well, we could, but we have to get them to the community colleges, because 50% of our students in our majors are transfer students. So we have to get those to the community colleges, and they have to articulate. General education is where they partly would have to exist. And so that goes through a whole process of getting them certified as we have area B4. And by the way, there's a law right now that's going through the processes about what general education will look like to help with these transfer issues between community colleges, CSUs, and UCs, because we all have different systems. So that's another issue. These associates for transfer that we have for mathematics and computer science require, calculus. And again, is calculus the right starting point? I don't think so. Yes, it is necessary. You are going to need to understand calculus for optimization in order to be able to move into a deep understanding of some of these more advanced machine learning methods. But it's not where you need to start to be able to do data science. So I think it's going to take a really big, it's going to be slow, because it's always slow to make institutional change at a large scale. But I'm really hoping that with these reports, both the MAA and the ASA, the American Statistical Association, the Mathematical Association of America, is starting to push, that will start to move. ABET is also starting accreditation processes for data science undergraduate programs. And so I think that will start to push some things in different directions when accreditation starts to be something that data science program seeks. So there's a lot of things happening right now. This is obviously something, this is why Eric threw it, something I care about deeply. But I think I think it's still a few years off before we get to something where we have like, these are recommendations from professional organizations about what Math 1 and 2, like how to integrate Math 1 and 2, and then we're going to have to move the scale on. It comes back to training faculty. Like, let's think about who is at community colleges and teaching institutions. Solomon, you can tell me if you agree, but most people, if they have a master's in math, but not statistics or data science, and that master's in math might mean that they specialized in topology, you know? So, and again, not that there's not applications of topology to data science, but there's a training aspect here that, and we've been dealing with this in the statistics side of things for a while. That's why we have the GAZE reports out trying to help mathematicians understand how to teach statistics. We are going to need, and those statements are starting to expand to include more data science. But again, we're going to need to think about how we are training and bringing training to mathematicians about how to teach these courses for data science. So it's going to be a haul. It's doable because we are moving it with statistics. And fortunately, data science and statistics overlap enough that I think we can bring data science with us. But my own statistics program is set up that it basically doesn't allow students to take statistics until like their sophomore year, which I hate. But it was built around an AST for transfer for mathematics that doesn't even require statistics as a possibility for transfer. So again, the system limitations make it difficult, but we can change the system. It just takes time. So fight with me, people, and we will revolutionize the first year of mathematics for these programs.
I'll just jump in here and just say a few things from my perspective. One is I did some data analysis a little bit related to what Solomon showed for equity and inclusion at, you know, who can make it into the data science major as written now at UC Berkeley. And Math 54, where people currently take linear algebra, is a place that students drop off. Like, you know, it's Math 1, Math 2, and then Math 54. It's just like, you have to take a lot of these math classes to get up to the data 100, to get to the upper division to unlock like the upper set of the Berkeley data science classes. And Math 54 is a bottleneck for diversity. And so what do we do about that? I don't have the answer, but I will say there's another problematic where right now, electrical engineering and computer science have a version of linear algebra, and stats has a version of linear algebra, and the math department has a version of linear algebra. And this is, you know, a bigger picture, you know, institutionally, but it's not efficient. Like, it would be efficient if there was a way to have a dialogue with the math department where math for data science was something that they were engaged with, not like the other people needing their students to have other skills, building other curriculum around them. Super tough nut to crack, you know. And the third thing I want to say is that there's also a ton of this conversation about math and data science happening at the high school level right now. And I don't know if you guys are tapped into that conversation, but it's fascinating. And they're like, do they replace 10th grade math? Do they, you know, just like abbreviate geometry and then make space for a second semester that's like giving people stats in 10th grade? Or is it something that comes later once they've gotten through a traditional sequence and is in place of calculus? Very interesting conversations, you know, and even like bigger and more difficult things to change. Because then you're involving like state standards and school boards, and like, you know, if you think working with the math department is difficult, imagine the 50 state departments of education and how they're going to feel about changing the math curriculum. But anyways, people are really talking about these shifts. I don't know if Aaron or Solomon, you want to talk about math for data science, or we should move on to another question.
Yeah, I'm okay to move on.
There.
Some of the other questions I had were in this in the slide deck at the end there. I guess one that I would like to touch on as a practical one, and I think Solomon touched on it. How do you get existing faculty to move into this new area of teaching. I would say, this is something that I personally do. I do a lot of outreach to faculty and trying to get faculty to teach with notebooks. And, sort of like, bring me your existing assignments and see if we can make notebooks out of them. I think San Diego has an amazing record at recruiting young faculty who are ready to go in new methods just by, being on the younger parts of their career. But I don't know if you guys want to comment on like efforts to attract people to teach in data science or like train them, Solomon.
Yeah, I think efforts to attract people really revolve around making it student-centered. So how does this help students? Because ultimately, I believe that most people that are teachers, they care about their students and their student success. So a lot of faculty just don't know. The student that we had a few years ago who was very motivated, was going across the state in order to find data science programs, reached out to a lot of community colleges and asked for data science. And one community college said, yeah, we have data science, we have data structures, right? And that goes to show that it wasn't on the purview of a lot of people that work at community colleges. So for them to know that this is a field, this is a growing field, and this is a field that can give students jobs and opportunities for a changing world, I think that that is the main push that you get in order to get people interested in it. And then you have to give them away, which I think has been so nice with the efforts with the California Alliance, working with Berkeley, working with Cal State Monterey Bay, with San Diego, of how do you get from where you are to where you can offer this course and offer it to students. And if you give people a pathway that's not too difficult, I believe that teachers will take it.
I'll jump in and say one of, my own personal background is in biomathematics and zoology. So I had this area of emphasis in statistics because that's the program I was under when I did my degree. And when I first started data science, literally wasn't a thing. Like when I started at CSU, analytics was talked about, and my PhD granting institution, NC State, had just started a master's of analytics, very business oriented. But when you start actually even looking at like Indeed.com and a lot of these graphs, it was 2012 that the term data science really started to take hold in the common vernacular. And so it's really that realization, like I had to go and seek out training. So I fortunately had Grant to help me with some of this. But there's areas, again, I am more on the statistics side of things, but there is a lot of overlap. So the Consortium for the Advancement of Undergraduate Statistics Education, or CAUSE, C-A-U-S-E, we have an electronic conference in the spring, and there's workshops, and I was able to engage in those workshops to learn more about things like data visualization and how to teach programming. I knew how to program in R, but how to actually teach that was another whole deal. Data carpentry or software carpentry does training, usually for free if you can find somewhere around you. And again, the CAUSE ones, the virtual ones are pretty cheap as well. If you have money, although you can apply for scholarships, University of Washington, there's biostatistics group has several trainings every summer, and you can kind of pick and choose 2-day workshops to go to up at University of Washington to train. So I think the more, those were some places that I was able to find training to help me start teaching some of these computing classes in a, not just again content, but also pedagogy, really thinking about that pedagogy. And so that's a big part, is making that accessible. And again, I had a grant to help pay for a lot of that for myself and for others. And so I really think it has to be, there has to be a little more of bringing it, to the people. We've gotten used to Zoom now, right? So doing more virtual, free to access, easy access, or low cost access workshops, I think will be transformative, especially for more rural community colleges and public four-year institutions as well. And then there's also, so yeah, that's a part of the training piece. But the pedagogy, like it's not just content, it's also pedagogy, because there is a whole different way of teaching computing. In my own department right now, we're actually maybe a little late developing a style guide so that we're modeling best programming practices, because we're all statisticians, none of us are programmers, but so we're modeling best programming practices. Like that's requiring a fair amount of retraining on my part to do that. And I saw there was a question I wanted to touch on too with the training piece. It asked about teaching assumptions and scientific methods. Ethics is big. Like, so again, it's not just about teaching, it's not about content, you know, teaching them the modeling and the programming, it's about the pedagogy, but then also the practice and thinking about helping our students to practice data science ethically and responsibly, because there are a lot of companies that are going to throw a lot of money at them. Is that something, you know, and some of these companies, they have to ask, is this somebody I am willing to support? And so really helping them evaluate that.
Awesome. Thank you, Judith. Yeah, we didn't even quite delve into the depths of context and ethics. I want to thank all the panelists, the great conversation. Thanks for the slide deck. If you're an attendee, check out the slide deck. There's so much good stuff that each of the panelists have put in there. Thanks for your great questions. Shout out to Nick Horton for always being like a stimulating person who's been part of this since way before I got involved and was, you know, has always been like a great leader here. I just wanted to throw up the slide and say there's a national workshop again happening next June. If you're that interested person, if you're from a community college or a CSU, we want to see you. It'll be hybrid and online, you know, there'll be an in-person part and there'll be a hybrid part. We generate a lot of materials. Everybody that you see here has been part of that and will be part of that conversation again. So thank you to ADSA for having us. And thanks for allowing us to broadcast our works in progress, but much more work to be done.
And thank you, Eric, and all the panelists. That was really amazing, stimulating conversation, so much food for thought and challenges for us all to think about and address. The intersections with community colleges and CSUs and the CU and the Alliance, that's not a small feat, bringing all of you together and being able to share your lessons learned and just plot paths forward. I love Judith's "come with me, we can make this change." I think that's a great incentive. I just wanted to shout out one last thing. I must have had some technical difficulties in my slides in the beginning because I managed to skip one, which is to say we have lots of more virtual content coming in 2022. There's at the tiny URL, ADSA virtual, ADSA virtual, all one word. You can find it or on our website. January 5th, so right after New Year's, we're going to continue our data science conversations with two HBCUs, Fisk University and Jackson State University. So we'll learn all about what they're doing in the data science space. Thank you again, Eric, for moderating, all of our audience for your questions, and thank you, panelists, for all of your talks and insights. This was really great. We wish all of you a happy, safe, and restful holiday season and see you in the new year. Thank you.